Now, sometimes we'll actually have a problem where we know the derivative of a function and we know something else about the function. We know one point on the function. And then we'll actually be able to find the big F that we've been talking about, the antiderivative, and actually find what C should be, an exact value of C. And when we're doing this, this is called an initial value problem. So they're often written like this. It says dy dx equals 9x squared minus 4x plus 5. And we know that y of negative 1 is equal to 0. Now, this dy dx, that's the same as saying y prime or f prime of x, the derivative of the function we want, is equal to 9x squared minus 4x plus 5. And we also know that f of negative 1, if we plug negative 1 into the function that we're trying to find, we get out 0. So what we're going to do here is, this is the same as our little f that we've been talking about. We want to find our big F, which would just be, unfortunately the notation is really bad here, our little f, since we have f prime. So f of x, we're going to take the antiderivative here. So we'd have 9, we'd raise that to x cubed, divide by 3, minus 4x squared over 2 plus 5x, and then we'd say plus c. Now we can clean this up a little bit and just say f of x. We can do 9 divided by 3, which would be 3x cubed minus 2x squared plus 5x plus c. So we're going to plug, now to find what c is, we're going to use this information. We're going to plug in negative 1 for x and 0 for f of x. So we'd have 0 equals 3 times negative 1 squared, cubed, that should be a cubed, minus 2 times negative 1 squared plus 5 times negative 1 plus c. So this would be, if we do that whole number, we'd have 3 times negative 1 minus 2 times 1 minus 5. So negative 3 minus 2 would be negative 5 minus 5. So we have 0 equals negative 10 plus c. So if we add 10 to both sides, we see that 10 should be equal to c. So the original function, what they're looking for now is y equals the antiderivative we found, 3x cubed minus 2x squared plus 5x plus 10. And we're saying if you take the derivative of that, how we can kind of check how if we take the derivative of that, we get back to what we started with, 9x squared minus 4x plus 5. And if you plug in negative 1 for x, you get out 0.